Okay, so now let's look at another vector space. Now this is the set of all polynomials of degree 3 or less. Okay, we can see that because we've got this polynomial expression, third degree, and where the coefficients are real numbers. Okay, so we could have any of these be 0, and we'd have a polynomial of a degree less than 3. Okay, so and then any constant polynomial, we'll consider that as a degree 0. So now this is a vector space under the normal addition and multiplication when we're dealing with polynomials, and this is worthy of taking a closer look at because this is something that you would find in a high school algebra class, right? As far as these types of operations, right? Now I'm not going to show all of the operations, or that it satisfies all of the conditions rather, but you can see that it'll definitely the closure, right? So if you add two polynomials together, you get another polynomial because you have to add like terms. So if you multiply this by a scalar, you're going to get another polynomial that's third degree or lower. So the verification that it's a sample space, or excuse me, a vector space, is easy. Now here's the interesting thing. Although P3 is not a subspace of any real vector space r to the nth power, r to the n, okay, or r to the 4, okay, but we can think of P3 as sort of quote unquote same as, and I use that loosely, same as R4. Okay, so if we identify these two spaces elements in this way, so if we take A0, oops, right, and we correspond that to this, right? So that the vector represents the coefficients of the variables. Then the operations also correspond. Okay? So here's an example, right? So let's take an example of adding two polynomials, right? So if I add two polynomials, right? So if I take that problem and I add, so I'm going to get right? And so that's going to correspond to this, isn't it? And so if I add the vectors, right, so it works out. So things we are thinking of as quote unquote same as add to the same sum. Now, we're going to work on a more precise idea of vector space correspondence later, but for now, we shall just leave it as an intuition of sorts. Okay, but we'll cover this more detail. So in general, we write piece of n as the vector space of polynomials of degree n or less. Okay, so in general, we would write piece of n is equal to the set of a0 plus a1 x1, or no, just x, plus dot 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 plus a sub n x to the n such that a0 to a sub n are real. Under the operations, the usual polynomial addition and scalar multiplication. And we will often use these spaces as examples. Okay, that's it. See you next time.